The last thing being covered in this video is going to be the squeeze theorem and running through an example explaining it. So let's talk about the squeeze theorem. The squeeze theorem says if we assume that the functions f, g, and h satisfy this, so f of x is less than or equal to g of x, and g of x is less than or equal to h of x for every x near a, except possibly at a. So what this is essentially saying, so we tend to use the squeeze theorem if we know that like a function that we're dealing with is greater than or less than a certain value here. So if we know that it's in between these two functions here, and we know the limits of these two, then there's a lot of assumptions that we can make about the limit of g of x then if it fits between these, right? We can say that the limits are the same because if the limit of this equals the limit of this, and g of x is in between that, well, it only makes sense that the limit of g of x would also be the same. So that's what the squeeze theorem is explaining. So we're going to run through this example here, use the squeeze theorem to verify that the limit of as x approaches 0 of x squared times sine 1 over x does equal to 0. Now, in order to understand this example here, we need to understand the sine function. And what we should hopefully know about the sine function is we know that the sine function, right, is a wave. Now, this is a really, really horrible sine graph here, but we know that the sine function looks like a sound wave here, and it goes up and down, +1, -1, all day long, back and forth. So we could claim and say that sine theta is less than or equal to a +1, but greater than or equal to a -1, right? Sine is always going to stay within these parameters. Now, if this is true, let's say that we're going to say that theta is going to equal 1 over x, right? Because sine of anything is going to be between +1 and -1. So we're going to say that sine of 1 over x is then going to be true for this here. It's going to be between -1 and 1. Now, we need to show that the limit as x approaches 0 of x squared times sine over 1x is equal to 0. Now, we do know that x squared is always going to be greater than 0, so it's going to be positive. So if I multiply everything that I have here by x squared, it's not going to change the signs of anything here. So I can say -1 times x squared, the sine 1 over x times x squared, and 1 times x squared. And I can multiply all three of these by x squared. Now that's going to look like -x squared is less than or equal to now x squared times sine 1 over x less than or equal to a positive x squared. So then we can just say, so let's find the limit of the left side. Let's find the limit of the right-hand side. So we can say the limit as x approaches 0 of -x squared is what? And then the right side, the limit as x approaches 0 of a positive x squared is what? Now, if we plug in a 0 here, so that's just -0 squared, which is just, well, there's no such thing as a -0, so that is 0. Same thing over here. If we plug in a 0, that gives us 0 squared, which is 0. So since we have claimed that the limit of the left side is 0, the limit of the right side is 0, it only makes sense then. So therefore, the limit as x approaches 0 of x squared times sine over 1x has to be 0.